are here to follow up on a conversation that we started, a very important one, on why buildings collapse. Sometimes one of the reasons could be that there was no proper supervision during concreting. So we want to see a very special case of a hollow pot slab and ask ourselves, what are the key areas as a structural engineer needs to pay attention to when they go to site to inspect a building just before concreting. Feel free to look keenly and send me a comment below. Welcome back. Last time we were talking about how to make sure that as a structural engineer in charge of a building project, you take responsibility, make sure you visit the sites, make sure that when the contractor tells you they are ready for concreting, you should go and check to ensure that what was designed and put in drawings is indeed what has translated on the ground. Therefore, you have to physically go for a site visit. What is it that you look for on a site visit? You check the formwork, check whether it is stable, and also make sure that you record whatever it is that you have given, because you write a report and give it to the contractor. Are the reinforcing bars, for example, in this case where we have a hollow pot slab, we have ribs, and it can be quite complicated. So you go section by section, inspect whether the reinforcement bars are the correct size. Check the edges. Look at the columns as well, the column starter bars. The starter bars, which need to have enough length for lapping. Ensure that the formwork is firm. The blocks, the hollow blocks are okay. Normally on a hollow pot slab, we recommend that the wet area is solid so that it's watertight completely. So you check that as well. You check the topping. Are there any spacer blocks? Even the stools which separate the bottom reinforcement from the top. Has the plumber placed their pipes where they're supposed to be? Has the electrician also placed their pipes where they should be? You go rib by rib, inspecting even the integrity of those hollow blocks. And remember, the hollow blocks need to be sealed on the edges, otherwise there will be a lot of concrete lost. Check the staircase as well. The staircase is normally solid, so the reinforcement can be quite dense. Check the beam reinforcement. Don't forget to check the sizes. Are they the same size as what they were designed for? Look very closely at how the staircase is anchored to the supporting walls, and make sure it is firm enough, because during concreting there will be a lot of weight, the live load during concreting, to make sure the integrity of your slab is not compromised. Check the anchoring, the sizes, the lapping. Are the lapping okay? Have the electrical conduits been properly placed? Are the risers and the threads on the staircase correct size? You measure. Check the lading of the staircase to ensure that it is as it was designed for. Check the supporting systems as well. Spend a lot of time on the site. Don't rush there and come back, because this is where you normally find there could be compromises. Check the formwork of the stairs. Ensure that the risers and the treads are firm. They have laddings also. Check to ensure that nothing has been done outside what it was designed for. The encouraging of the reinforcement into an existing wall, supporting wall. Check very closely, as you can see there. Don't be in a hurry. You ensure that what you as the structural engineer designed is indeed what is on the ground. And this, remember, should be done one day prior to concreting, so that you don't interrupt the concreting process. And you can't even do a good inspection on the day of concreting. So this is a demonstration, once again, for how a site inspection prior to concreting needs to be done. It has to be done thoroughly, and make sure also that the formwork is clean. Make sure that the spacer blocks are in place. All the formwork is firm. We are trying to avoid incidences of collapse of building. This is day 1, or the day before the concreting, a very important day, because if there are any faults, then you are able to point them out, and then the contractor and his workers should be on the ground to make sure that any comments that are given at that particular time are adhered to, and any rectification is done. This is the day before the concreting, and it's a very important day. This is normally when things may go wrong. Make sure that everything is ready. You don't want to come back and start hacking and breaking concrete to put in even conduits. Check the edges very carefully, and the landings just at the, so that when you come now on the concreting day, you'll find that the only thing now you need to check is the vibration in order. So the concreting day is also a very important day. This is when you ensure that the concrete is placed properly, the vibration is done properly, to avoid what is known as honeycombing. And they should be done immediately after an inspection and an approval to proceed with concreting. Remember, concreting should not proceed before a go-ahead is given. It's very important. Ensure that the concrete is properly vibrated, especially inside the beams, and the leveling, the trowering, as you can see. Have the inspectors on standby to make sure that this is done. You don't want to come back later and find that the concreting was not properly vibrated. So on the day of concreting, the key thing is to ensure that the concreting is well vibrated into the beams, into the ribs. At the same time, there is quality control. Take at random cubes, which will be taken to the laboratory for testing, to ensure that the grade that was specified is indeed what has been used. So here you can see quality control in progress. This is quality control in progress. We use standard cubes, and the following day you'll find that having completed the concreting, that is how your slab should look like. Should be smooth, evenly leveled, and after 24 hours, curing has to take place. Curing is normally done by spraying water or putting sand and wetting the sand in places where it's very hot. And this way, you have achieved a good quality concrete. Thank you very much for watching this short interview or interlude, or you may call it a demonstration of how is it that we can ensure our buildings will not be compromised. Thank you for watching. This is Education Without Borders. Keep watching, keep learning.